Knowledge could exist in a community without every individual understanding the mechanism. You already live like this. You probably eat foods every week that you could not safely identify in the wild. You do not know which mushroom species are deadly. You may not know which part of a cassava plant contains the most cyanogenic compounds. You probably cannot explain exactly why kidney beans need proper cooking. And none of that stops you from eating lunch. You inherited a food system. The supermarket is just the latest version. Long before regulation, packaging, and ingredient labels, humans were already outsourcing food safety to collective memory. And your own brain still carries the older emergency system too. Most people have at least one food they cannot stand because they got sick after eating it once. Maybe the food was guilty. Maybe it wasn't. Your brain rarely schedules a retrial. That system is blunt. Culture is more precise. Your stomach says, never again. Your group can say, this one is safe if you prepare it like this. That is a much bigger upgrade, and it changes the berry scene from the beginning. The person on the ground may learn never to eat that berry again. The people around them may become cautious too. But the real human advantage comes later. Someone remembers the plant. Someone warns the next group. Someone tells a child. Maybe the warning is accurate. Maybe it gets exaggerated. Maybe another generation discovers that only one part is dangerous. Maybe they learn that cooking changes it. The knowledge keeps moving even after the original event is gone. That is how the risk stops resetting with every generation. Ancient humans did not survive poisonous plants because every person became a perfect botanist. They survived partly because one person's lesson could become everybody else's information. The first person might have paid dearly for the mistake. The second person just ate a berry nobody has tried before. Purple-black, glossy, looked harmless. An hour later, they're on the ground clutching their stomach. Everyone else is still holding the same berries. Now what? For most of human history, this was not an abstract question. People moved into new valleys, new forests, new coastlines, and unfamiliar landscapes full of plants they had never seen before. No field guide, no poison control hotline, no tiny skull icon floating over the dangerous ones. So how did humans figure out what was safe to eat without poisoning everybody one plant at a time? The useful answer comes early. Most people did not start from zero. They inherited food knowledge from other people. Which plants were eaten, which were avoided, which parts were safe, which had to be cooked, which needed soaking, pounding, drying, fermenting, or some other suspiciously specific ritual before anyone touched them. That solved a huge part of the problem, but it creates a worse question. Somebody had to learn the rule first. So what happened before the rule existed? Your brain has one crude but effective solution. Remember the food that made you sick. Psychologist John Garcia became famous for experiments showing that animals can form a strong aversion to a taste after it is followed by illness, even when the illness comes much later. That delay matters. Touch a hot surface and the lesson is immediate. Eat something toxic and the punishment may not arrive for hours. A normal learning system could easily miss a connection. Taste aversion doesn't. One bad experience can be enough, and the brain can be unfair about it. Psychologist Martin Seligman once described getting sick after eating bayonnaise sauce and developing a powerful aversion to it afterward, even though he later believed the illness was probably unrelated to the sauce. His stomach had made its decision. Case closed. For an omnivore, that kind of learning is useful. You do not gain much by testing the same poisonous dinner twice. But one person's memory only protects one person. Humans had a better trick. Other people's knowledge could become yours. A child does not need to personally discover that a certain berry causes vomiting if every adult in camp refuses to touch it. You do not need to understand plant chemistry if the oldest person in the group says, "Not that one." You do not even need to know why the rule exists. You just need the rule to survive. That is where culture becomes a survival technology. A warning can outlive the person who first learned it. A food taboo can travel across generations. A preparation method can be taught to children who never saw the mistake that created it. The lesson separates from the accident, and suddenly trial and error gets much cheaper. Not free, just cheaper, because humans still made mistakes. They still confused plants. They still ate things that hurt them. The advantage was not perfect knowledge. It was that every new person did not have to repeat every old error. Plants are inconvenient like that. They do not reliably advertise danger. Some toxic species look completely ordinary. Worse, some resemble edible relatives closely enough to cause modern poisonings even when people have books and photos available. Poison hemlock is one example. Its white umbrella-shaped flower clusters and finely divided leaves can resemble edible plants in the carrot family to an inexperienced forager. There is no universal visual rule that says, this plant kills you. Bright color is not enough. Bad smell is not enough. Bitter taste can sometimes warn you about certain compounds, but it cannot certify a plant as safe or unsafe. Nature did not build a labeling system for us. So human food knowledge had to get specific. Not red berries are bad. This berry, this leaf, this root, this season, this preparation. That level of detail is hard for instinct. Culture is much better at it. And then humans did something even stranger. They stopped merely avoiding some toxic plants. They learned how to eat them. Cassava is a perfect example. Today it feeds hundreds of millions of people. But cassava contains cyanogenic compounds that can release cyanide, especially in some varieties if the plant is processed badly. So communities develop processing methods that reduce the danger. The exact sequence varies by place and by product. Grating, soaking or fermenting, pressing, drying, roasting, cooking. Different traditions use different combinations. The important part is that the procedure matters. Do it properly and a dangerous plant becomes food. Do it badly and harmful cyanogenic compounds can remain. Nobody had to understand cyanide chemistry for the method to work. The recipe knew more than the cook. Not literally, obviously, but functionally. Yes, a sequence of actions preserved cause and effect across generations before anyone could explain the chemistry underneath it. That is cumulative culture doing something remarkable. One person notices that soaking helps. Another changes how long. Someone else grates the root first. A later generation adds another step. Nobody invents the whole system in one afternoon. The method gets smarter slowly. The people using it do not need to know every reason why. That pattern shows up all over food history. Fermentation, cooking, leaching, drying, roasting, removing particular parts of plants. Humans kept discovering ways to change foods that were bitter, hard to digest, toxic, or otherwise unpleasant. And then culture kept the successful versions. That is much more powerful than waiting for evolution to redesign your stomach every time you enter a new ecosystem. It is also why the question, how did ancient humans know, is slightly misleading. Often, one person didn't know. The group knew, or the grandmother knew, or the rule knew, or the recipe knew.